Hello students, Triham Pratikta Sansthan welcomes you in our very next topic, units and its measurements. Units and measurements. It is the topic of class 11, chapter number 2. We are going to discuss in this topic the part 1, which is covering the measurement and about the units and how can we use the units and their system, their respective system. Okay, let us discuss about first what is the measurement. A measurement is the process. Measurement is the process of comparison of the given physical quantity. Is the process of comparison given physical quantity with a known standard quantity of the same nature. Okay, जैसे मान लेते हैं हम लोग कि कोई ऑब्जेक्ट है सपोज इतना बड़ा और कोई ऑब्जेक्ट है इतना बड़ा, राइट? देन हम ये नहीं कहेंगे ये इतना बड़ा है ये इतना बड़ा, हम इसको मीज़र करेंगे किसके लोग जो हमारा स्टैंडर्ड है. तो हमारा स्टैंडर्ड है मीटर, तो वी कैन मीज़र इट इन दैट इट इज़ ऑफ 3 मीटर, इट इज़ ऑफ 5 मीटर, नॉट say that it is of 1 hand length, it is of 2 hand length, it is of 4 feet length, and not it. Okay, now give an example here. There's a measurement of length using vernier calipers and measurement of diameter of wire using screw gauge we can use from it. So this is the measurement. So I think it is clear that a measurement is the process of comparison the given physical quantity, and we have also some standard quantities also, right? Now come to the next topic. There's a parallax method of measurement. It is used by the astronomers. And the parallax is called. What is the parallax? So first of all, we have to learn about the parallax. What is the parallax? Parallax is that look that this is a candle, right? And you are going to see with both eyes, and just close your one eye and look again on it. Then you feel some difference of its position. That position is parallax. Okay, like this object. Here is the object after closing your eyes, and here is the object with the both eyes. Then this is the difference. It's called parallax. It is generally used to determine the objects, determine the difference of object, determine the distance of object which are very far away from the earth, like stars, planets, and all that. Okay, it is used by the astronomers. Now, units and their types. How can we say the units and their types? Unit is the quantity. What is the unit? First of all, you have to decide the unit. Unit is the quantity of a constant magnitude which is used to measure the magnitudes of other quantities in same order. Okay, what is the unit? Unit is a quantity. Unit is a quantity of a constant magnitude. The magnitude should be constant, and it is used to measure the magnitude of other quantities in the same order, right? Means if we are measuring a distance from A to B, then it is the quantity is also used to measure from distance Kanpur to Lucknow, from Delhi to Mumbai, from India to Pakistan, and all that. Okay, this is the length, right? Similarly, if we measure that this is 10 kg, if we measure that this is 100 kg, then we are going to measure the weight of a truck, a train, a pole, a planet, then in kgs. Okay, kinds of unit. Then how many kind of unit there? That are fundamental units and derived unit. Fundamental unit and derived unit. These are the two types of the units. Fundamental unit, that units that are not depend on any other unit. Means we can say that the free units are called fundamental units. Free units are called fundamental units, and they are not depending upon any other units. These are of 7 types. Further we have studied in this chapter after a few minutes. The second one is derived unit. Derived unit is generally obtained from the fundamental unit. Means if the fundamental unit is length denoted by d, distance is denoted in length, and the time, then distance upon time, whatever, it's the velocity or speed, then speed is the derived unit, and fundamental unit distance and time. Okay. However, there are some very small distances also. So, very methods are applicable to derive the small unit, small distances. One of the most popular method here described with the help of oleic acid. This is a simple method for estimating the molecular size of oleic acid. Molecular size, a very small distance. We know that the mole, a very small distance, right? The size of oleic acid, how can we measure it? Look at that. What is oleic acid? Is a soapy liquid. It is a soapy liquid, which with a large molecular size of the order. So, a monoleic molecular layer of oleic acid is first formed on the water surface. So, this is the water, right? And add the oleic acid in it. Add the oleic acid in it. Then what happens? It forms formed on water surface, a monomolecular layer. In the water surface, it formed a monomolecular layer. Okay. Then oleic acid is dissolved in alcohol. Then make a solution of this, and then take and dilute the solution. Then take the solution and dilute using alcohol. ओके यानी कि पहले हमने इसको क्या किया, पानी में लिया, पानी में मिलाया तो इसने मोनोमोलिकुलर लेयर एक बना दी, इसके ऊपर एक लेयर बना दी. फिर उसको क्या किया हमने अल्कोहल में डिजोल्व करके उसका सोल्यूशन बना दिया और सोल्यूशन को अल्कोहल के साथ डाइल्यूट कर दिया. ओके, सो द कंसंट्रेशन ऑफ सोल्यूशन इज इक्वल टू द कंसंट्रेशन ऑफ ओलिक एसिड पर सीसी ऑफ द सोल्यूशन. क्यों किया हमने, जिससे कंसंट्रेशन दोनों जो वाटर है और जो इसमें है वो दोनों क्या हो जाए, इक्वल हो जाए. नाउ व्हाट आर गोइंग टू नेक्स्ट सम लाइकोपोडियम पाउडर. Some lycopodium powder is lightly sprinkled. कुछ पाउडर लिया हमने लाइकोपोडियम पाउडर, उसके ऊपर स्प्रिंकल कर दिया थ्रू, and 1 drop of this solution. Take the 1 drop of this solution and put it in water. The oleic drop is spread onto a thin, large and roughly circular film of a molecular thickness and water surface. Then the diameter of the thin film is quickly measured to get its area. When we put this in the point, then get a thick sheet, a thick layer in that area. Suppose we have dropped water initially. We determine the approximate volume, say V in centimeter cube. Volume of the drops of the solution, say there are many drops could be in a water, then we measure the number of n, and so total volume whatever n into. Then amount of oleic acid in this solution is given nV into 1/20 upon 1/20. 1/20, 20 is the molecule. Okay, is the volume. Check. Now come to the next. Now this solution, whatever the solution we get of oleic acid spreads very fast on the surface of water. Spreads very fastly on the surface of water and forms a very thin layer of thickness, say T. At this spreads from a film of area A. Then thickness, what is T? Volume of the film upon area of the film. That is NV upon 20 into A. NV upon 20 whatever is the volume, and A is area of the film. Then we can get from this formula the thickness T of the oleic acid molecules. Here's the process. I hope you can understand that. Okay, just pause the video and understand this, and if there are some difficulties, kindly comment in the box and I will make it sure. Okay, now units and its need. What is the need of unit? Why units are needed? Okay, we know that measurement means the comparison of an unknown quantity. Measurement, as we said earlier, the measurement is the comparison of quantity. The quantity is unknown. Okay, this known fixed quantity is called, that is, which quantity to which we have to compare is known as unit. Okay, The result of measurement is expressed in two parts. The result of measurement is expressed in two parts. One part is a number and other part is a unit. That is, we denote the unit in this form, n into u, where n is a number and u is the unit. Okay. For example, if I going to a shop, then say vegetable, and if you need some potatoes, you are going to say, give me kg potatoes. No. Yes, isn't it? No. You are going to say, give me 5 kg potatoes, give me 6 kg potatoes, give me 10 kgs potato or any other vegetable. So what is 10? 10 is the number and kg is the unit. So we can write the unit along with number only. Okay. Hence, what is the need of unit? A standard measurement unit is needed as a general method of measurement, like measuring from hand, palm, foot, varies from person to person. It always gives error in the measurement. So, the unit is needed. Okay. Why we need a unit, a standard measurement? Okay. Because the general method, as you have earlier lesson from your grandparents and mother or father, that in the later eras, we used to, that the thing is 5 hand long, this one is 5 hand long, this one is 20 steps away from this, then we are using 5 hands, 20 steps. But these are not the authentic way. These are not the authentic. We can vary, because if you are going to using your step, and if you are going to use your little younger brother, which is approx 5 to 6 years, his step, many differences. Difference varies a lot. If you cover a distance, suppose with your legs, it in 10 steps, and with the help of your younger brother, maybe it's around 20 steps. Then the difference is there. So, to avoid this variation, a measurement is required, that is a unit. That is a unit, and it is a standard measurement. Okay, that was the problem on measurement. Now, what are the system of units we have? CGS, MKS, and FPS system. In the CGS system, what is stand for CGS? Centimeter, gram, second, S, G, and C. Okay. Then take the first letter CGS. The centimeter, gram, second system of units, abbreviated as CGS or CGS, is a variant of the metric system based on the centimeter, where centimeter is the unit of length, the gram is the unit of mass, and the second is the unit of time. Another one is MKS. Here length is in centimeter, and here length in meter. Here weight in gram, here weight in kilogram. Here time in second, here also time in second. Okay. This is the MK system. In the beginning of physics, where the so-called CGS system based on the centimeter, gram, is commonly used in the theoretical physics. But nowadays, a MKS system is a standard system. Using to determine and measure the units. The next one is FPS, the foot pound second system, or FPS system, is a system of unit built on the 3 fundamental units, that is foot for length, pound for mass, and second for time. Now, let us study about the basic standard units of measurement. Basics of standard unit of measurement. In ancient India, where the length was measured using hand, mutti, fist, but measurement from it is not accurate, as we have earlier discussed. Hence, French. Here is the important. Who created this? French created it. Hence, French created a standard unit of measurement that is called metric system. Then, if you are going to be asked who discovered the metric system, these are the French who discovered the metric system. Now, metric system is further classified to the SI system, System International, Standard International System, and CGS, and second system. Okay, metric system now again divide into the MKS, means SI system, and CGS system. Take. Okay, forge. An SI system unit of length meter is denoted by forge and has 100 division, one division per centimeter, which is the unit of length in CGS. Forge is the unit of length in CGS. Simple problem to find distance in the light year. Why we are not using the CGS as a system, standard system? Is not a simple problem to find the distance in light year. The product of magnitude of a quantity and numerical value of its corresponding unit. A good unit has the property. What is good unit? We are studying here. Good unit has a property that the magnitude in the corresponding unit system is neither too large or not too small, and the values are easy to compare. Okay. We are here to study why CGS system not taken in the standard system, because a good unit has the product of magnitude of quantity and numerical value of its corresponding unit. The good unit should have the property that the magnitude in the corresponding unit system is neither too large nor too small, and the value are easy to compare. For example, it is convenient to express the distance between two cities. If we are going to see tell the distance between Kanpur and Delhi, what will be the easy way? Determine the distance in kilometers or centimeter, right? Kilometers. It is easy rather than using in centimeter. Okay, so the SI system of unit decided that the unit have the smaller value, a very higher value cannot be taken as a standard. So to taken as a standard system of unit, the international system of unit defines 7 units of measure as a basic set. 7 units of measurement as a basic set, which all other SI units are delivered. SI base units and their physical quantities are as a meter. Meter is used for length. Kilogram, which is used for mass. Second, which is used for time. Ampere, which is used for electric current. Kelvin, which is used for temperature. Candela, which is used for luminous intensity, and the mole, which is used for amount for substance. These are the 7, 1, 2, 3, 4, 5, 6, 7 fundamental quantities, which is our international system. Identification of units and quantities from each other. It is possible to define a unit for a given physical quantity. For example, length and distance can have the unit of meter, inch, miles, light year. That's us. It is possible to estimate the physical quantity from its units. However, it should be noted that the multiple quantities can have the same unit. And hence this estimate is not accurate. So if a quantity is given us, then it can represent work or some form of energy. Okay, so the identification of units and quantities from each other should be there. Like if we are going to measure the meter, length is in meter, then this is also length and this is also length, right? For a rectangle, the length and breadth both are, if the distance and the distance both all are the representing in meters. Okay, this is the representation. Common measurement units is in daily life. Just remember these unit length. 1 decimeter we use is 0.1 meter, 1 centimeter is 0.01 meter, 1 kilometer is 1000 meter, 1 cubic centimeter is 0.000051001. It is 1 cubic centimeter. If we are going to study about mass, 1 kg of mass having 1000 gram, and the time 1 minute have 60 seconds. Now common units for measurement in the daily life, that is 1 feet, 1 square feet, 1 centimeter, 1 acres, 1 acres. In practice we use only round of values. Say 4.2 then we use only 4, but 4.7 we use 5. That is the rounded off. We are going to study of in the next chapter what is the round off. Okay. Value of the above physical quantity. Now, what are the physical quantity? Physical quantity is a quantity in physics that can be measured. Suppose this is a quantity. We can measure its length, we can measure its breadth, we can measure its length, we can measure its area, we can measure its volume. Okay, so we can measure everything. A physical quantity is a quantity in physics that can be measured. Okay, so which quantity can we measure? Which have the physical property that can be quantified. Means it should have some physical property. For example, it should have mass, it should have amounts of substance, it should have length, it should have time, it should have current, light, intensity, whatever, velocity, density, many other things which should have the physical quantity. These are the physical system of unit. In mechanics, length, mass, and time. The fundamental, we have already studied the 7 fundamental units, but in mechanics, and especially in mechanics, length, mass, and time are the 3 fundamental quantities. Length, mass, and the time are the 3 fundamental quantities for the units of these basic quantities. The following system can be used, as we already discussed: CGS system, length in centimeter, mass in gram, time in second, FPS, foot, pound, second, MKS, meter, kilogram, and second. Okay. Now, prefix of exponent. If it is given that the mass of an object is, that it can also be written in megagrams. It's a higher. Okay. Now, guidelines. Important thing: guidelines for writing the units. How can we write the guidelines? Okay. The symbol for a unit which is not named after a scientist written in a small letter. For example, meter. It is not on the name of scientist. It can be written m. Second, it cannot be on the name of the scientist. It can be written as s. The full name of the unit, irrespective of the fact whether the name of the scientist or not, is always written with a lower initial letter. Okay. If we are going to written the full form of the unit, say this is denoted by meter, and if we are going to written 4 ME, then we written METRE, M as a capital. Here example, kilogram. Then K is capital. Okay. This is the wrong way. This is the wrong. When in the short way we are using small m, then also if we are going to written in full form, we use the lower cases. That's meter. Lower initial cases. It's from starting from the smaller format. If it is from in the name, or if it is in the name of scientist, then we are going to use the capital letters. A compound unit formed by multiplication of 2 or more units, written after putting a dot, cross, leaving a space between the two symbols. Like if we are going to unit of torque, that is Newton meter, the N, M. We can separate them by using dot, or using a space, or using cross, whatever. But we have to show some sign to separate them if we are going to use more than 2 units, 2 or more than 2 units. Negative power is used for compound unit, which is formed by dividing one unit by another unit. A unit is in its short form is never written in plural. In plural means if we are going to written 10 meter, we know that 10 is plural, but we don't written it in 10 meters. This is the wrong way. This is 10 meter, not 10 meters. Okay. So 10 meters cannot be written as 10 meter in short. But if we are going to use the whole, then we written 10 meters. 10 meters. To avoid power of 10 in the magnitude of a quantity, prefix can be used. If we have the power of 10 in the magnitude of quantity, then prefix can be used with its unit. But a unit must not written with more than one prefixes. With more than one prefix. For example, if we are given written with more than one prefixes. For example, it should be written as and not what, some other common units, means second. If we are going to second, millisecond, minute, these are another units are there. J, R, so units of time. Other common units of time is smaller unit. If we are going to say smaller unit of time is millisecond, microsecond, nanosecond. Bigger unit of time, minute, hour, day, month, lunar month, year, leap year, decade, century, millennium. So higher, bigger quantities. Now SI unit of length and identify its subunit. The SI unit of length is meter. The SI unit of length is meter. So what is the definition? Definition given by Weight and Measurement Conference on Weights and Measures CGPM in 1983 given the definition. The meter is the length of the path. The meter is the length of the path traveled by light in vacuum during the time interval of a second. During the time interval of a second. Okay. Subunit of meter is a centimeter, millimeter, micrometer, micron. These are the subunits. If we are going to convert it, then metric units of length 1 meter in 1 meter, that is 100 centimeter, 1000 millimeter, 0.001 kilometer. In 100 meter, just multiply it by 100. In non-metric units means inch. In 1 inch, that is 1 by 12 foot, 1 by 36 yard, 0.00126 tan. These are the units. Instruments to measure with time. Now, in the instrument that are used to measure the time are clock. Basic time measurement is clock. It works on the principle of periodic motion. Clock, it's working on what? Periodic motion. This motion is called periodic motion. Clock are different types, like table clock, digital clock, wall clock, etc. Simple pendulum is the basic instrument to measure the time period. What is the basic instrument to measure time period? That is simple pendulum. Simple pendulum is the basic instrument to measure a time period. Now take some other example of clocks. There is sundial. It says stick or object that causes a shadow on the horizontal surface. As the sun moves across the sky, the position of the shadow moves in the dial face to indicate the time. Means it's depend upon the sun. When the sun, and here is the object, and here is the shadow. As soon the sun is rotating here, then the shadow is going to change its place, and we can calculate the time according to that. The least count of such sundial again varied a great deal and improved from about 1 hour to about 15 minutes on the later age. Now, water clocks are also there. Very evenly marked container. Evenly marked container over there with a float and pointer into which the water dripped in a fixed rate. It's like this, and this water is filling after say 1 minute, 2 minutes. Then here are the marks. Then with the help of filling water, we can measure that. It measure in 1 hour, it measure in 2 hours, it measure in 4. This is the way. The least count of instrument varied a great deal, but people were happy to have at least count of about a quarter, and the least count was sand clock. You have seen the movies, and also the ear is like this, and you put the sand here, and after a centimeter in a month, this come here, this come from here, and stay here. Then after 1 minute, it will empty and it will full. Then it take the time approx. It is also a type of clock which I use our letter area, our former areas. Atomic clock. This one is the new atomic clock. Atomic clocks are the most accurate timekeepers ever. Atomic clock are most accurate time-giving machines. The best one loses 1 second. Only plus minus 1 second is the time lag only in this. In 190 days, approximately 2739726 here. This means that once synchronized from generation from your family number need not to reset the clock. That is you know if you have set the time, then your family window after 2 7 3 9 7 2 6 years after it used to reset that clock. Okay, then this is the most accurate clock. Identification of fundamental, how we identify the fundamental quantity. A fundamental unit is a unit adapter for measurement of base quantity, as we have already studied about this, and can be expressed in terms of conventionally chosen subset physical quantities. Physical quantities on a subset quantity can be expressed in terms of length, mass, time, electric current, thermodynamics, intensity, as we earlier learned about this. Now, definition of SI units. Definition of SI units. That was unit of length. What is the unit of length? Meter. The meter is the length of the path. The meter is the length of the path traveled by the light in vacuum during a time interval of 1/2979245 of a second. Isn't it? 299799245 inverse a second. Unit of mass. The kilogram is the unit of mass. It is equal to the mass of international prototype. Kilo, right? Unit of time. Second. The second is the duration. The second is the duration of 91926317770 periods of the radiation. 91926317770 periods of the radiation corresponding to the transition between two hyperfine levels of the ground state of cesium 133 atom. Cesium 133 atom. Now current amperes. Current unit have ampere. The ampere is that constant current which is maintained in two straight parallel conductors of infinite length of negligible circular cross section and place it 1 meter apart in vacuum would produce between these conductors a force equal to the Newton per meter of length. Okay, these definition you should have learned, and generally not these are not coming examination, but for your general knowledge you have to learn it. Again, the unit of temperature, that is Kelvin. The Kelvin unit of thermodynamics of temperature is the fraction 1/273.6 1/273.6 of the thermodynamics temperature of the triple point of what? 1/273.10 of the thermodynamics temperature of the triple point of the water. Unit for amount of substance, that is mole. The mole is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kilogram of carbon 12. 0.012 kilogram of carbon 12, and its symbol is mole. Unit of luminous intensity, that is candela. What is the definition? Is given direction of a source that emits monochromatic radiation of frequency 5401012 hertz, and that has a radiant intensity in the direction of 1/683 watts per stereo. Okay. Now, what are the derived quantities and their unit? Derived quantities are the quantities which are expressed in the terms of fundamental quantities, as we have already studied, and based on 7 basic fundamental quantities like these. Some commonly used derived units which include, we know here is pressure, F/A, mass density means M/V, specific volume L cube, density, magnetic field strength, capacitance, and all that. All other the units that are depend upon different units means not free from other are known as derived unit. Okay, many of units are there. The units of all quantities other than the fundamental units called derived unit. Derived units are obtained in terms of fundamental quantities. For an example, as we have studied, area, length into breadth, that is meter into meter, and its unit is meter square. Volume, length into breadth into height, length is in L, this is in L, this is in L, then meter cube. How can we write the SI unit? The convention followed while SI units. Only units of the SI and those units recognized to use with SI should be used to express in the value. Should be used to express in the value of what? Quantity. Should be expressed in the values of quantity. All the unit names are written in small letter. Along with all units names are written in small letters only except Celsius. In Celsius we use C as a capital, while Newton, a kilogram we use N and K. If only use abbreviation, then N will be capital, but in K, G is small. The unit symbol in lowercase unless the name of the unit is derived from a proper name, which in the case of first letter of the symbol is in uppercase, as we studied. Unit symbols are unaltered and plural. Unit symbols are unaltered and plural. Unit symbols and units names should not be mixed. Abbreviations such as second, SEC, for either S or second, or amperes for either meter per second or meter per second are not allowed. Okay. So we have to manage it. Okay, written second for S, not SEC for either. Okay, amperes written like meter per second, not ampere, because it can be m by S or meter per second. It is not allowed. Okay. For units value more than 1 or less than minus 1, the plural unit is used. A singular unit is used for value between 1 or minus 1. Okay. A space is left. A space is left between the numerical value and the unit symbol, like 25 kg, but not 25 kg, not like this, not like this. Take some space, 25, then kg, 25, then kg. Okay. If the spelled out name of the unit is used, the normal rules of English are applied, whichever we are going to use in our grammar, that are using. Now, dimensions formula. The dimension formula is defined as the expression of the physical quantities in term of basic unit with the proper dimension. Dimension formula of two quantities is given by the dimension formula is given by, for example, angular momentum of physical quantity is given by its dimension. Can be quantity like dimensions in m, l, and t. M for its weight, its mass, kg, L for its length, and T for its second. The correctness of physical equation using dimension analysis. Checking the correctness of physical equation is based on the principle of homogeneity of dimension. What is this principle says? Only physical quantities of the same nature, having the same dimensions can be added, subtracted, or equated. Not the others, not the difference. To check correctness of given physical equation, the physical quantities on both sides of the equation are expressed in the terms of fundamental units. That is m, l, and t. Same on both sides of the equation. Okay, which is correct, otherwise it will not correct. By using this, we can establish a relationship between the physical quantity. So, dimension is an expression of the character by delivered. Dimension is an expression of a character of derived unit in relation to the fundamental quantity without regard for its numerical value. It is only showing the dimension, not its numerical value. In any system of measurement, such as the metric system, certain quantities are considered fundamental and all other are considered to be derived from the base. Okay, what are the limitations? Now, look at the other limitation. Dimension analysis has no information on dimensionless constant. We can't say about the constant with the help of dimension. If a quantity is dependent upon logarithm, trigonometrical, exponential, if suppose this is sine theta, cos theta, e की power, e goes to power s and all that, we cannot use this dimension formula. In some cases, it is difficult to guess the factors while deriving the relation. Connecting two or more physical quantities, we can't express it. The method cannot be used in equation containing two or more variables with the same dimension. Therefore, a dimensionally correct relation may not always be actual correction. For example, if cannot be used, the physical quantity is dependent on more than three unknown variables also. If there are two unknown variables, if there are three unknown variables, we can't use the dimensions accurately. This method also cannot be used for the physical quantity contains more than one term also, say sum or difference or two terms. It does not allow us or tell us about the exact form of the relation. It does not tell about whether a given physical quantity is a scalar or vector. We cannot identify the quantities scalar and vector property through the dimension equation, through the dimension formula. So these are the some problem we are going to face when written quantities in the dimension form. Well guys, this is my video for the first part. In the next second part we come with the significant numbers and the errors. In the next video we are going to study about this, and soon I have to launch another video of having numerical problems from first chapter. So keep watching this channel, and kindly subscribe and share to your friends. Thank you.